Welcome to DfRSoft's instructional video on qualification testing. Qualification testing and test planning is not simple. It can be fairly complicated. There's a number of expectations between your customer and what you think is a good qualification. And what DfRSoft has done is it provides you with a good start for your design for reliability, for design maturity testing, and statistically significantly coming up with an estimation for your failure rate or MTTF that you've achieved on testing, while at the same time providing you with the standard tests that are acceptable and the process flow that is necessary. For example, on qualification testing for assemblies, in addition to high temperature operating life, temperature cycle, and testing humidity, you're going to want to be doing CPK analysis. You're going to be doing visual inspection and pre and post CPK analysis. There may be a pre-test bake. There could be vibration involved. There could be a drop test, physical integrity, ESD testing, destructive physical analysis. These are the kinds of things that are done on qualification testing for assemblies. And similarly for hybrids or something like that, you can have a test plan for hybrids or plastic or semiconductors where you have different objectives for your failure rate objectives, and you might be testing at a certain confidence level. And how do you come up with a sample size? Well, the test time and things like that. DfRSoft makes it very simple for you to do complex qualification testing and do it in a repeatable fashion. So what we're doing is basically the basics for most of this is, for assemblies, they're usually the combined high temperature operating, temperature cycle, and temperature humidity bias are fairly common to both assemblies, semiconductors, and hybrids. So there's different kinds of tests for each. Like in assemblies, there's all vibration testing, where in hybrid testing you also want to be including leak testing or different kinds of, instead of vibration testing, you might do constant acceleration. Semiconductors, you're not going to be doing vibration testing, so all these things have to be taken into account. So the goal is to come up with an automated capability for you to have a structured method for doing what is industry standard qualification testing. You're going to have the ability to put in use environment, test durations, and you have using your standard models and your statistics and your reliability models, come up with a design maturity test with a process flow card so the test can be conducted. And with a test diagram. So let's go over to DfRSoft and see how this is accomplished. First, you'll scroll down to, you should be watching our video also on test planning. It gives you an indication of the chi-square method and things like that, which we're not going to get into on this on qual planning, but it is the basis for a lot of the analysis. So we hyperlink over, and the first thing you're going to do is put in your you need to activate this. You need to activate your card, and you need to put in the activation code, which is not supplied during your 30-day trial period, but you can take a look at what is there. And you have to choose, say you're doing semiconductor, you can choose hybrid or assemblies after you, and let's say we're doing semiconductors. So the semiconductor, whatever test you're doing, to the right is the test results. Here's the process flow card for semiconductor testing, and there is your test plan. That for semiconductors, you have an initial sample size, you have your visual inspection, then you go into both your non-accelerated test area and your accelerated testing. You're going to start off with CPK testing. This is industry fairly standard JEDEC type of testing that is knowledge-based, and it provides a very good basis for what you want to start off with. If you need to modify this, you can. If you need to call us and say we need this specific modification, we'll do that. So basically, this is the test plan. So you have the three tests: temperature cycle, temperature humidity bias, and high temperature operating life. Final CPK analysis. On the non-accelerated testing group, you have ESD, You have a control group. You have your destructive physical analysis and your physical integrity. These are the common industry standard, and then you have a process flow card for each. And you're going to, with your inputs, it'll come out with your sample size planning and things like that. Similarly, for hybrids, a hybrid process flow card is next to that. If you select hybrids, you have your process flow card, and down below will be your, for hybrids, your test planning. You have initial sample size, control group, fine and gross leak testing if it's sealed, preconditioning, temperature cycle, high temperature operating life, etc. You have your ESD and your physical instructor and DPA. And notice on the diagrams you have some letters here. So for example, what that means, if you look at, you're going to line it up like the H, temperature, humidity bias, H, come over here and you'll see the sample size is 26 for your inputs. So that's how you read those diagrams. And there's also some letters, B10, and it corresponds to the process flow card. Finally, for assemblies, is your last process flow card. And so there are process flow card if you're working on assemblies. And you can copy and paste this into Excel on your sheet, and you can add and delete lines, and it provides you with your model inputs. So this is your assembly process flow diagrams and some of your options. The other thing that's very convenient in DfRSoftware, when you do this test, down below is not only gives you your, what you've achieved in terms of your failure rate, but also gives you your expected findings. If you do the sample sizes here, it provides you with a statement, qualification testing has been performed on 123 devices, etc. It tells you your failure rate, your non-accelerated testing results. So it basically knows from what you've inputted and outputted in your statement there. You need to once you start learning about it, you'll see it become very obvious how that expected results evolves. So when you get over to the heart of the test planning is provided here, and how you use it is provided right there. And you select whatever you're doing, semiconductors, hybrids, or assemblies, and the heart of everything is in this section right here for your inputs. So this is your inputs for whatever you've selected. And these inputs, let's look at that. So for semiconductors, you enter your project name, the project manager, your origination date, the work order number, enter the ID for the test type and the test versions, and or your part number. Your reliability objective is very important. For here we've entered an objective of 400 fits. Notice at the 60% confidence level, and the number of allowed test failures. And this video will be part 1. There'll be a part 2 video as well, so we don't have to rush through this because this is a lot more complicated than the normal testing. So for part 1, we're doing semiconductor testing. We've introduced everything. And then you come down, and with that objective, you can it'll figure out the optimum sample sizes for your test parameters. So for temperature cycling, you can put in 200 cycles, the low minus 55 to 150, and the use delta temperature. And there's also a sample size override if you don't want the routine to figure out the use of the optimization routine. Right now we're going to go terminate this part 1 video, and you'll have to go to part 2 video to find out the rest of how this works, and we'll pick up from where we left off. And hopefully you'll go to that video, and you'll get more details on how to do all the specifics for this test. Thank you, and see you in part 2.